In this chapter, we will be studying sequences and series. In this lesson, we're going to study arithmetic series.
All right, hi everybody. So in this lesson today, we're going to talk about arithmetic series. Now, last lesson we talked about arithmetic sequences. And a sequence is just a pattern. Now, specifically what our focus is here is a pattern of numbers. And in a sequence, you separate all the different numbers in the sequence with a comma. So you've got this sequence of terms, this list of terms here separated by commas, and there's this little rule for helping you determine one term to the next. Now, in an arithmetic sequence, all we're doing is adding a constant number every time. So we start, for example, in this case, we start at 2, and then in this particular case, I add 2. So to get to 4, add 2 to get to 6, add 2 to get to 8. A series is when we add all of the terms in a sequence to get the sum, okay? Now, we got to pay attention that there will become some concerns here if the sequence stretches out to infinity and we convert it to a series. Sometimes an infinite sum works, sometimes it doesn't. And so we're going to take a look at that later on here. So to kind of deal with that right now, what we typically do here is, specifically with arithmetic sequences and series, they're going to be finite. Okay, we're going to stop at a certain point and then add up all the terms there. So 3, 6, 9, 12 is an arithmetic sequence, and as soon as you throw in the addition signs there, it becomes an arithmetic series. Okay, so here's the real comparison here. An arithmetic series is the sum of the terms in an in an arithmetic sequence, is what that should have said. An arithmetic series is the sum of the terms in an arithmetic sequence. Now, before we get into the formula for how this works, I'm going to tell you a little story. Now, I'm going to tell you the story as I heard it. Okay, now, whoops, my hand is all funky. There we go. I'm going to tell you the story as I heard it. Now, that should give you a sense of the veracity of the story, whether it's believable or not. I don't know. Okay, but the story goes, as I heard it, that we're talking about Gauss, a young Gauss. Now, as far as I was told, and this is just one version of the story, imagine this very famous mathematician, probably one of the greatest mathematicians that ever lived. The story goes that while he was in elementary school, he was being a bit obnoxious during class. He was being a bit of a brat, and the teacher was getting frustrated with him and said, "Gauss, that's it, I'm done. Out in the hall." And she said, "What I want you to do out in the hall is I want you to take the numbers 1 through 100, add them all up." "Okay, don't come back until you're done." "Okay." So Gauss goes out, comes back in a few moments later and says, "Here's the answer." And she looked at him and she's like, "Oh my gosh, how could you have the answer so quickly?" Because she was assuming that would take him quite a while. And he explained that what he did is he said, "Well, you wanted me to do this. 98 plus 99 plus 1. You wanted me to add up all the numbers 1 to 100. Well, I noticed that if I rearrange those numbers, okay, plus 3, plus 2, plus 1. If I rearrange all the numbers and add down, so I have two sets here, every time I add straight down, I'm going to get 101. All the way down. Every single pair that I get there, it adds up to 101. So if S is the sum that I'm looking for, okay, I've got the sum here, I've got the sum here. I added those together. That's twice the sum. So it's going to be that sum of all those 101s. Well, I already know there's going to be 101. So that's 10,100. And if I divide by 2, I'm going to get 5,050. So the sum must be 5,050. Now, that's probably not true. He was intelligent enough, though, that it certainly has it rings true, but not verified. It hasn't been verified as far as I know. But anyway, that is the pattern that we use to build the equation that we're going to work with. Formula, we're going to do the exact same thing that Gauss did, or at least the hero of that story did. So we know that the general term of an arithmetic sequence, Tn, is going to be T1 plus n minus 1 times d. Okay, and so after the first term, we keep adding d's. Now that's kind of how we're going to build this. So I'm going to figure out the sum of the first n terms. So that's going to be the first term plus, now I got to be careful when I write this, the second term plus the third term. Now hopefully that makes sense what I'm doing here, because remember, to move from one term to the next I just keep adding d. Now we're going to keep doing that until we get up to, well, this is going to be the first term plus, let's say, n minus 2 times d. And then remember, our last term is going to be t1 plus n minus 1 times d. That's because that's our formula, right? That's the general term of our formula. That right there would give me the nth term. And I'm adding up to n terms. If I rewrite this sequence underneath, I'm going to move that back here. I'm going to get t1 plus n minus 1 times d plus t1 plus n minus 2 times d. That's the second last term, plus dot dot dot. Now, maybe I should even erase this one so it's not confusing, so we're not getting that confused with anything here. Those are my first two terms, my last two terms. Now I'm going to switch that around. There's my second last term now, and there's that last term. Now, if I add these things all up vertically, and I hope this makes sense, I hope this n minus 1 times d makes sense, that would be the last term over here, that if I want the second last term I'd have to subtract 2 from the n and multiply by d. Now I'm adding vertically, so there's going to be 2 nth sums. And now watch what happens, ignoring everything else, just look at those two terms. When I add those together, I'm going to get 2 t1s, and then I'm going to get an n minus 1 times d. Plus, now, watch what happens when I add those together. Again, I'm going to get 2 t1s. Now, this might be confusing, and maybe I'll write it down here, but I'm going to get a d plus n minus 2 times d. Now, I'm just going to clean this up a little bit. That's going to be n times d minus 2 times d. When I put those together, I'm going to get nd, okay, that's this guy right here. D minus 2d is minus d. And if I factor that d out, I get n minus 1d. Oh, that's interesting. This second term looks exactly like the first term. Now, that's exactly what happened, what little Gauss, okay, if that's who it was, that's what little Gauss showed us. So every term should be exactly the same. So we're going to go dot, dot, dot. This is going to be out here, t1 plus n minus 1 times d. Whoops. Wow, that was terrible the way I wrote that. And then lastly out here, it'll be 2 times t1, and I'm right at the end here, plus n minus 1 times d. Okay, that's a little messy there, but you get the idea. Now it's going to get cleaned up real quick, because I know, because I knew from the start here that I was adding n terms, I know that there are going to be n of these. So this is going to be n times 2t1 plus n minus 1 times d. There's going to be n of those. And now to get Sn by itself, I would divide by 2. And right here, that expression right there allows us to find the sum of the first n terms. Now, this is not S times n. This is n. This is supposed to be S subscript n. Okay? To tell us that we're finding the sum of the first n terms. It's going to be the number of terms divided by 2 multiplied by twice the first term plus the number of terms minus 1 times d. Now, we can change this up a little bit here by doing one small little thing, n over 2. If I take that 2t1 and just write that as t1 plus n minus 1d, and I haven't really done anything, but notice that when I split that up here, t1 plus n minus 1d, that is tn. So another way of writing this formula would be to write that this is n over 2 t1 plus tn. And there's a second formula that we could use for finding the sum of the n terms in a sequence. And actually, when we go back to our workbook here, you're going to see that these are the two equations that you're given. So the sum of the first n terms is n divided by 2 multiplied by 2t1 plus n minus 1d. And we identify the variables. T1 is the first term, n is the number of terms, d is the common difference, and then s sub n, this is all one symbol really, is the sum of the first n terms. Or if you know the first and the last term, okay, T1 is the first term, Tn is going to be the nth term. Okay, that's Tn. But if you're only adding n terms, then that Tn must be the last one. Okay, so there you go. I hope that makes sense. Now let's going to take a look at some examples. All right, so here we go. So use a formula to find the sum of the following. Now, okay, we could just very easily just plug those numbers into our calculator, but that's not the point here. So notice that the first term is 17, and that every time we go up, okay, when I take the second term, subtract the first term here, I can see right now that my common difference is 5. Okay? Now, I also know if I count this up, there's 1, 2, 3, 4, 5, 6, 7, 8. There are 8 terms, so n is going to equal 8. So now, the sum of the terms in a sequence here, I can actually, at this point here, use either one of the formulas. And maybe what I'll do is I'll do both. 2 times t1 plus n minus 1 times d. That should also equal n over 2 t1 plus tn. Now let's just plug this all in. So I am now looking for the sum of 8 terms. So as soon as I replace that n with an 8, every n gets replaced with an 8. T1 we saw was 17. This is going to be 8 minus 1, and then d was 5. Okay, if there's some consistency here, if I do 8 divided by 2, T1 is 17 and Tn is 52. These should be giving me the exact same value. So just go to my calculator. 8 divided by 2 is going to be 4. 2 times 17 plus, that's 7, multiplied by 5. And I'm getting 276. Now, let's see if that equals the same thing over here. 8 divided by 2 is 4. 17 plus 52. And there we go. 276. Okay, so the two formulas agree, they both work, and they agree. Awesome. So let's just keep going, and we'll take a look at just some different ways these questions can get asked. Find the sum of the first 10 terms. So right away, even without looking at the sequence, I know that I'm looking for 10 terms. I can see from my sequence that the first term is equal to 2. I also know, just by taking and subtracting a couple of times, 8 minus 2 is 6. 14 minus 8 is also 6. Therefore, my common difference is 6. Good to go. Now, I don't know what the last term is. I could very easily figure out the last term. I could, because I know my general formula for the arithmetic sequence. That's fine. But I don't need it, because I can use the sum of n terms as n over 2, 2 times t1 plus n minus 1 times d. This formula here works without knowing what the 10th term is. So the sum of the first 10 terms will be 10 divided by 2. As soon as I replace that n with a 10, all the n's get replaced by 10. My t1 is 2. This will be 10 minus 1, and I know that my d is 6. Once I've got that all in, that's just calculator work. So 10 divided by 2 is 5. 2 times 2 is 4. 10 minus 1 is 9, multiplied by 6. And we get that the sum of those terms is 290. Okay, please use the equation. Please don't write out the first 10 terms. In a case like this, you could do that quite easily. Okay, I'm not saying that would be hard, but in this case right here, that would be needlessly difficult, let's just say. All right, now in this case, let's determine the sum of the following. This next one here. Now, in this particular case here, I don't know how many terms there are. Now that's going to be a bit of a problem, because in both of the formulas that I discovered here, or that I showed you here, I needed to know the number of terms. So that's going to be an issue here. I'm going to have to come back to that in a second. I do know that the first term is 3. And when I compare the first and second terms and the third and second terms here, I can see right now that my D value is going to be 4, going up by 4. Okay. Now, I know the last term, so I feel fairly confident that I'm going to end up using Sn is going to equal n over 2 T1 plus Tn, the nth term. Now this right here, this last term here, once I figure out what n is, that is going to be my nth term. So that's going to be the Tn. 3 is going to be the T1. But what I got to do here first is figure out some way of getting the n value up for 59. But that's actually not as hard as it sounds, because I know, like if you drop the plus signs here, I know that this is an arithmetic sequence. So I can use the general term of my arithmetic sequence to figure out what the n is. Okay, because I know everything I need. The last term there, the nth term is 59. First term is 3. I don't know what n is, but I know that d is 4. So I know everything about the general term of the arithmetic sequence except for the n. So this should be relatively easy to figure out. So I'm going to subtract the 3 from both sides. So I will get 56 is going to equal n minus 1 multiplied by 4. I would divide both sides by 4, and 56 divided by 4 is going to be 14. Then add the 1 over, and so I get that 59 is the 15th term. So now I can go and say, okay, I'm going to add together the first 15 terms of this sequence. First term is 3, and I already know the 15th term is going to be 59. So now I go to my calculator, 15 divided by 2, multiplied by 3 plus 59. And here we get the sum is 465. Okay, works out really, really nicely here. Now, this question right here, just to be fair, this is probably one of the more challenging questions that you will look at in this chapter, merely because the variable that you're missing requires you to go back and work with a different formula than the one that you might instinctively go to first. Okay, so just something to consider. Let's take a look at another one. It says the sum of an arithmetic sequence with 10 terms is 195. Okay, so I'm telling you that S10 is equal to 195. If the last term is 33, so that means the 10th term is 33, we are looking for the first term. Okay, well, if I think back on my two equations here, I do have an equation for the sum that requires me to use the first and last terms. It's this one right here. So if the sum is 195 when n is 10, I can plug in 10 in for n. I don't know the first term, that's the whole point, but I do know that the 10th term, when n is 10, and I can see that n is 10 right here, that's going to be 33. Okay, so this is 195 is equal to 5 multiplied by t1 plus 33. Well, I'm going to take that 195, divide that by 5, and I will get 39 is equal to T1 plus 33. And then you simply add the 33 to both sides, and we get that our very first term, the T1, is 72. Just a little bit of manipulation of the equation is all that is. Okay? In many ways, what we're doing in this chapter is we're practicing our algebra skills with a tool and a context here that's actually quite useful in many different contexts. Let's go on and let's take a look at some more questions. Actually, I find this rather enjoyable. Okay, this question here says the 8th sum is equal to 204. I'm giving you that D is 5. We want to find T1. Okay. All right, I know that the 8th sum is 204 here, so it tells me the n is 8, and I know what that sum is. So, and if I'm looking for T1, but I'm giving it D, that's got to be this formula right here, 2 times T1 plus n minus 1 times D. Because this is the only one of the two formulas that we've got that uses the variable D in it. So I know that when n is 8, Sn is 204. So I've got to make sure I put the 8 over here. T1 is the variable, so I leave that as the variable. I know that n is 8, so that's going to be n, or 8 minus 1, and then multiplied by 5. Okay, so this is going to be 204 is equal to 4 multiplied by 2t1 plus, okay, that's going to be 7 times 5, so that's going to be 35. Now, I'm going to divide both sides by 4. I could multiply that through, but I think it's a little quicker. Just let's divide both sides by 4. So 204 divided by 4 is 51. Sorry, this would be 2t1 plus 35. So now we're going to take that 35, bring it over. 51 minus 35 is 16. Now divide by 2. And we get that t1, the first term in this particular sequence, is 8. All right. Find the sum of all multiples of 7 between 1 and 999. Okie dokie. Well, all right, that's a good question here. Now, first of all, notice that if we're talking about multiples of 7, we got to make sure that you're really clear on what's meant by this. I find that a lot of times people don't actually, if you ask them, do you know what I mean by multiples? The answer is, until I say, okay, what are they? Then it's like, oh, no, I was just kidding. I don't know what you're talking about. Okay, multiples of 7. 7 multiplied by 1 is 7. 7 multiplied by 2 is 14. 7 multiplied by 3 is 21, and so on. These are your multiples of 7. Now notice in this pattern here that these always go up by 7. So we form this little sequence here, and d is equal to 7. Now, I want to know the sum of all multiples of 7 between 1 and 999. Now, 1 is not a multiple of 7, but after 1, the first multiple of 7 is 7. So the first actual multiple that I get to after the number 1, because look, I'm looking for between. So after number 1, the very first multiple of 7 is the number 7. That's my first term. So this is great. I know 7 is what I'm going up by. I know that I start at 7. But we've seen this before. The issue is I don't know what n is. Now, I could go up and use my calculator and start playing around with 999 and subtract numbers until I get one that's a multiple of 7. Or I could just do this. This would be lazy. I'm going to use my general term. I want you to see this little bit of math here. I'm not suggesting this is the only way to do this. This is one of a few different ways that you could probably play this thing through here. But let's pretend, that 999 is in fact a number in that arithmetic sequence. So we're going to figure out what the n value is. I know that my first value is going to be 7. I don't know what n is, but I know that I'm going up by 7. So now I'm going to take 999 and I'm going to subtract 7 from it to get 992 is going to equal n, whoops, wow, don't know why I wanted to say plus, n minus 1 multiplied by 7. I'm now going to divide 992 by 7. That is going to get me 141.7142 blah 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 equals n minus 1. And now I bring that one over and I get therefore that n is equal to 142.714 blah blah blah. Okay, well, it doesn't make sense for us to have an n value equal to some decimal number. We don't count numbers like that. We don't count terms in the sequence like this. We don't go, this is term 1, this is term 2, this is term 2.5, this is term 2.6. We don't do that. So what that means is, if the math is telling me that 999 is the 142.7th term in the sequence, that means there were 142 terms before that. So, and therefore, in my particular sequence here, n is going to be 142. And so now I can use my summation formula. Plus n minus 1 times d. I know that this is going to be the 142nd sum, so this will be 142 divided by 2, 2 times 7, plus 142 minus 1, going off the screen there, multiplied by 7, and now this is just calculator work, so 142 divided by 2, multiplied by, well, that's going to be 14, plus that's 141 multiplied by 7. Putting that all together, oh, that's 71,071. Okay, that's a big sum. But on the other hand, we are adding together a whole bunch of multiples of 7, so it makes sense that that would be a fairly large number. Let's take a look at another one. An exercise program asks that you walk 20 minutes the first day and increase the time by 5 minutes per day. On which day would you have walked a total of 6 hours? Now, don't misinterpret this. I'm not asking on which day did you walk 6 hours. Okay, and I hope you don't take the pattern there that seriously, that's what would happen here. Wow. What we're saying is here is if you add up how much you've exercised, when is the total 6 hours? Okay. So let's take a quick look at these numbers here. We know that T1 is going to be 20 minutes. We know that our D is going to be 5 minutes. Okay, because we're increasing by 5 minutes every day here. And what we're looking for here is we're looking for a total, a sum. I don't know what day that's going to happen on, but of 6 hours. Now, the problem is we've got a change in units here. So what we're going to have to do here is we either have to convert the minutes into hours, and then we're working with decimals. This is kind of weird here. Or we could easily turn that 6 hours into 360 minutes. That's a little bit easier to get our heads wrapped around. Now, I don't know how far, or for how long we walked on the last day. I need to figure out which formula to use, and I don't know how far we walked on that last day. So I'm going to use this one right here, which is 2t1 plus n minus 1 times d. Now, I am looking for n. I'm looking for n. I'm trying to figure out how long or how many days this took. So I'm going to put our sum in there, 360, n over 2, don't know what that is yet. But I started at 20 minutes, so 2 times 20. This will be n minus 1, don't know what n is, and I know that d was 5. Okay, so first of all, I am going to multiply across by the denominator because I want to get rid of the fraction, don't want it. This is going to be 40 plus 5n minus 5 when I distribute that back. So 720 is going to equal n multiplied by 5n plus 35. Now, distribute that through, I'm going to do this two things in this one step here. I'm going to bring the 720 over, and I'm going to distribute that through. So 5n squared plus 35n minus 720. Oh boy, look at what I've got here. Everybody, that's a quadratic. This whole thing is a quadratic. This is why we're looking at this in this particular course here. Okay, because of the presence, once again, of this quadratic here. Now I'm highly lazy, so I'm gonna do myself a bit of a favor here. I'm going to divide everything by 5, and I can do that as long as you do it to both sides. And that's going to be n squared plus 7n minus 144. I am really hoping that this factors, but the truth is I know that it factors. Okay. Usually we look at 144 and people are quick to jump on and say, that's 12 times 12, and you're absolutely right. That's also 16 times 9. So when you do this, you're going to get negative 16 or positive 9. Now, in the context of this question, the negative n, actually in the context of this chapter, the negative n doesn't make any sense. Okay, that's not how we count off values here. So this must have been 9, so therefore we walked 9 days. Okay, If we follow that particular little pattern there, by the time we've walked 9 days, for 9 days we'll have walked for a total of 6 hours. Let's do one more. Oh, stacking cans. Yep. It's always an arithmetic series there. So stores often stack cans for display purposes. To calculate the number of cans in a display, an arithmetic series may have been used. Suppose a store wishes to stack the cans in a pattern very similar to the one shown here. This display has one can at the top, and each row thereafter adds one can. If there are 18 rows, and right here, how many cans are there in the display? Okay, 18 rows is our n. Our first term is 1, and every row we add 1. So actually that's kind of nice. I like those numbers there. So we're looking for the total number of cans in that display. Now, see, it wouldn't surprise me if a lot of people just opted to just adding those numbers up really quickly, trying to, at least on a calculator here. But you can actually use this formula right here to do that. I'd argue a little quicker if you are familiar with the formula. So we're looking for the sum of the first 18. So that's going to be 18 divided by 2. 2 times 1 plus 18 minus 1 times 1. So that's going to be the sum of the first 18 rows is going to be 9 multiplied by 2 plus 17. Well, 2 plus 17 is going to be 19 multiplied by that 9 out front. There are 171 cans in that particular display. Knowing how to work with these arithmetic sequences, series here, just makes those kinds of calculations just a whole lot easier to do than trying to do it piece by piece, or your calculator trying to hit those buttons real quick to get all 18 there. And the more work you do like that, the more likely it is that you do make a mistake. So please avail yourself of those formulas that we've given you.